Hello, hi everyone. Today we are going to learn preparation of piperine with the detailed mechanism. Okay, so what is the starting material we are going to take? This is a catechol in the presence of chloroform and potassium hydroxide. This potassium hydroxide is the strong base which will convert to this 3,4 diol benzaldehyde. So this reaction is similar to the but Riemann-Diamond reaction. Okay, Riemann-Diamond reaction. In that case, we can take the phenol in the presence of chloroform and the base sodium hydroxide or potassium hydroxide we can take. So in that case, we can obtain the salicylic acid. Okay, so but in this case, we are obtained 3,4 hydroxy benzaldehyde. So again we are going to take the CH2I2 and sodium hydroxide. So this reaction is called as the condensation reaction. What is this condensation reaction means? The two or more molecules combines to form larger molecules. Okay, these larger molecules will become eliminates to give smaller molecules. Okay, so here the product will form piperonol and after that the CH3CHO, okay, acetaldehyde and the base sodium hydroxide which will give the this kind of substrate. In this case we are going to take the acid anhydrous and sodium format, but I didn't mention here sodium format, so this is my mistake. And in this case the pipperic acid will be formed. Then this pipperic acid in the presence of PCl5, it will give the pipperic acid chloride will be formed. Okay, this PCl5 is act as the chlorinating agent. It is acts as a chlorinating agent and it is also acts as a catalyst. Okay, but in this case we can use the chlorinating agent. Okay, then piperidine, after taking the piperidine we can obtain piperine. So this is the reaction, but next we can discuss the mechanism. Okay, mechanism. First we can take the catechol, then chloroform in the presence of base potassium hydroxide, it is the strong base, and we can obtain from this 3,4 diol benzaldehyde. Then we can take the CH2I2 and the base sodium hydroxide which will form this one. And so how it will be formed, that means here 2 Hi will gone, 2 Hi will be removed and CH2 will be formed here, here. Okay, so then next step I am going to take the acetaldehyde and base. Okay, then this substrate I am going to modify. Okay, so which will gives the carbanion. This carbanion will be attacked to the carbonyl carbon, and here carbon attached with the double bond oxygen. These bond is migrate to the oxygen upward, and then next this hydroxy group will be removed. How it is removed means, here one of the sodium hydroxide we took, this sodium hydroxide again here will become, okay, this sodium hydroxide, one hydroxy group will be abstract the proton from this hydrogen. So hydrogen will be become minus H2O, and this bond will going to the migrate second position of the carbon. Then there is double bond will be formed, and next we have to take the acetic anhydride and sodium acetate, which will give the uh, anhydrous carbanion. This anhydrous carbanion here will be attached to the carbonyl carbon, and next we can obtain this by the using of sodium hydroxide. One more sodium hydroxide, the hydrogen will be abstracted, the water molecule will be removed, hydroxy also is removed, then pipperic acid will be formed. Then in the presence of PCl5 we can get the this product, and in the presence of piperidine we can get pipperic acid and HCl. That's all. Thank you.